So next up we have Anthony Kazub, the product manager for Wardbeck Systems, and he's going to be talking about routing audio signals, so how to get these things through your network. So Anthony, take it away.
Hello. My name is Anthony. I'm the vice chair of the Toronto Audio Engineering Society. I'm the product manager for a Canadian company called Wardbeck Systems. We built mixing consoles when they were mixing consoles, and now we've had to make the decision to go into IP. So we study a lot of domains of IP. What I noticed, and Arista said it best yesterday, was that we've gone from 2 layers to 7. So I want to talk a little bit about the really low-level audio problems that I've started to play with, examine, and find solutions for. Obviously, we're here to talk about the standards that the Audio Engineering Society, the Society of Motion Picture Television Engineers, deal with, as well as how they work together and how they interop with one another. Unfortunately, now we have flavors within all of these flavors and subsets within all of these subsets. So I understand the confusion that it causes to the industry. So coming to events like this and hearing Andreas speak and all of these speakers come together has been hugely beneficial. So I'm a big fan of that. Right now, there are several really popular discovery methods for streams. You've got Ravenna, SAP, ISO, Quarry, and myself, and I were favoring, because I'm an audio engineer, the attention to AES 70, but the subscription and method is put into the user's hand and to the user's experience. AES 67, there is not yet a logo that is on the back of a piece of equipment that says this is an AES 67 piece of equipment. What the Audio Engineering Society is working towards is a protocol implementation compliancy specification for manufacturers to have some commonality and all of these different levels certified through some type of certification process, thus giving you some logo that you can put on the back of your box to trust. This is part of the works of the Audio Engineering Society. Audio is is way more malleable when it's on a network. What broadcasters and content creators are looking to do is split up the control and the source into multiple different pieces. I no longer look at a television station as a control room tied to a control room and a set or an outsourced source going to a control room. I look at it like a pool. And by pool, I take the analogy of AES 67 and audio and video and all of these things. It's like taking a can of soup and dumping it into a pool and then going to the other edge of the pool, pulling out that can of soup and consuming it like that. But what you have is a label around that can of soup. And that is the label that makes all of this possible. So you can break television and radio production down into several pools. And usually these pools are managed by production departments. Any show can be broken down into a host and his co-host, some type of ambience microphones, some type of guest. There's always a hardwire backup. There's a hardwire backup here. So we follow these protocols and these ways of doing things. And then ultimately, we transmit this, we record this, we archive this, and we put it away. There are many methods to make these connections. Like I say, Ravenna is a popular connection. Dante supports AES 67 through SAP announcements. Then there's just manually moving the SDP around, and then there's automatically moving the SDP around with APIs for that. As Andreas said, there are different levels of receiver conformance. In my opinion, we should drop the A and just be, this is level 30, which has 8 channels, 1 to 8 channels. And then we have higher packet speeds. But that's politics behind all of this stuff. Customers want to say, well, is it -30 compliant? I want to say yes, not which flavor. That's one of the things as a small manufacturer we have to deal with as customers get into this space. Ultimately, there is a talent, there is a position, and there is a performance. My talent ID, well, that's part of a database that generated this show. My position ID is dictated by this microphone, and the show is dictated by my time slot as a part of this event. And I look at all of these things as unique things. So I've represented them as barcodes for a couple of reasons, but you get the idea. It doesn't matter what it is. So this was the old mixing console, and these are the domains of the mixing console. So you had an XLR, and you had a preamp, and you had a filter, and then you patched it, and then you had the faders to play Fuzi on, and you could mute it, and you had meters, and you matrixed it, and you bussed it, and you summed it together, and you amplified it. But now with audio over IP and AES-67, all of these things can be broken down into their component parts. Like Andreas was saying, an EQ is now a resource on a network that you can push and subscribe to. You can have a digital audio workstation handle all of this routing for you natively on a computer. The session description protocol is exactly the thing I want to move around with all of this information. The SDP is the label on the soup can that I dump into the pool. So that is a common thing between all of these manufacturers. And there's different ways one can implement a parser, and there's different ways that people can implement the parser as it relates to their receiver. So not all receivers process an SDP the same, but most can consume an SDP. If there's a line in the SDP that the receiver does not recognize, it simply ignores it. So I want to leverage that. In most situations, there's a who, what, where, and why. So the who has an ID, the what, the where are they plugged in, and the why are they plugged in always has a unique ID. In the registry of IS-04 and IS-05, you have that in a registry. You have those unique things as part of a registry. But if you were to take a network and distribute those processing things across a network, you can start doing some very creative things with mixing and summing. So for example, in this case, I have a host, and this is the most important person on the show. And this host has a co-host, and this host generates a unique multicast, and the co-host generates a unique multicast. Well, my host can subscribe to my co-host. My co-host can subscribe to the host. With that, devices now have the capabilities to do summing. So what you do in one of these devices is you create a sum of the host and the co-host. And what I'm doing is feeding that back to the guests. And what I'm able to do is create mix minuses with people. I'm able to create a mix minus of her minus her. This guest here can receive this guest, and vice versa. So all of these people are receiving different streams that make up their mix minus. So if you segment a network, and if you segment your workflows, you can achieve things that have never been possible in the analog domain. The SDP in the soup label wrapper plays an important part of this, because this stream contains everybody. If this person were to consume a stream that they were in, it would cause feedback for the whole loop. So there are certain things you need to do in the SDP and the SDP management and the SDP filters that has not yet been touched on in any of the standards. Ultimately, a unique hardware ID, a unique control receiver ID ends up in the cloud, and there's going to be DSP in it. Right now, we have DSP on a laptop or a tablet running, essentially. So this DSP is starting to become a microservice on a computer that you can spin up, and that is changing the way that we are mixing audio. So I created these. I think 3 of these are up right now. They're tests for experimenting with this equipment. When all of this equipment shows up to the IP showcase, it ends up in a spreadsheet. So SDN, I say spreadsheet-defined networking, because it seems to be the most common thing. So when I add a device to the network, the organization asks for details about it. So I call that a pool pass. And with a pool pass, you get the MAC address of the device, the physical dimensions of the device, what one would call an inventory of your devices. So security, I'm going to go level -1 security is you have a device. First thing is you know a device. And if you have a database of those devices, you can then leverage that real data about the devices to program the network. Talent, well, I'm a person, I have this unique code, I have a Lisp, and I can introduce a preset into that person's personality. If I know what microphone is on their face or that they're in front of, I can know how they react to that type of microphone and store that information as part of my talent. But talent at a source is a show that I can push off into the SDP. So my soup label wrapper becomes very, very important. Like I was saying, well, I have a physical location. So this is here. It is this model number, it is this manufacturer, it is this MAC address. With IS-04 and IS-05, what you have is you have those hooks and handles into the APIs to get that information. Geopositional location, I'll talk a little bit about that, and what actually switch port that it's plugged in. One of the smartest things that was done at this interop was, well, as soon as the show started, they locked off all the ports. Nobody could get in. You had to have, there's certain secrets I can't say, but they had certain criteria for your device to actually be able to turn on. And you would not be able to know those unless you were part of the engineering scheme of the network. There are tools such as Merging's Animan, which deal with the connection and disconnection through segmentation. Like I said, I don't view the network connection as a matrix anymore. I view it as a pool. With the tool like this, I pool together the devices that are part of my production, and it only routes the things that I care about and the things that I'm paying attention to. This tool is growing as a platform, but it takes industry and customer demand to push for adoption of something like this. This is a free piece of software that I highly recommend checking out and using on as much as you can. The case study that I wanted to talk a little bit about was an awards show we did for a network in Canada called Bell Media. Bell Media allowed us to come in, and I built a network on top of their production, kind of for fun as well as for experimental purposes. Partnered with Merging, Artel, and obviously Ravenna to make it happen was very important to us. Having these types of interops introduced us to these types of products, and we use them for reasons that I'll explain later on. The show was set up as a two-stage event, a center stage, as well as an awards stage. They had microphones everywhere. They had absolutely everything for this show. No expense spared. The audio was set up traditionally. You had a lot of XLR cables, you had a lot of wiring, and you had a lot of labels. And I like this because the labeling of everything makes everything happen so much better. So I started this talk, or advertised this talk as being, well, what used to be a piece of tape and a Sharpie marker is now this dynamic database that is on a network. So when I did this show, the technical producer of the show gave me all of the information I needed in an online spreadsheet. So we leveraged Smartsheet. You could leverage Office 365. You could leverage Google Sheets to get this type of metadata to actually label your devices. But taking this another step further, you could actually be labeling the streams. This was a 15 camera layout. I don't know where these are, West Jib, Steady Center. So ultimately they fall into pools. So we needed to get the ambience microphones, we needed to get the live music, the guests, the backup, and the host RF. Then they threw another challenge at us. They wanted to do a live ATSC3 object-oriented mix simultaneously. So they gave us the challenge of setting up microphones and setting up arrays so they could actually mix in real time a Dolby encoded Atmos stream to be spread out to the world. We came up light. We came up with 3 little tiny road cases and 4 laptops, and we said, sure, we'll capture 100 channels for you. That shouldn't be too big of a deal. We broke it down into the cameras. Every camera had a stereo microphone. Every camera pointed at different directions at different times of the day, so we started paying attention to some of that. But ultimately, the ambience microphones started to form these pools. So if somebody was in the center pool, this microphone that's pointing over here is going to pick up relatively nothing compared to the excitement that's happening in the environment around the center pool. And same with the awards stage. As the focus of the show changes to the awards stage, the microphones that are pointing to the backs of the people sound like microphones pointing to the backs of people. And the whole point of this immersive experience is to make people feel as if they were there. And it takes shifting that image to give that illusion. The West Pool, East Pool. Then we shift backstage, and you cannot have the same ambience in a backstage throw as you do when you're in the show. So these environments move from a very simple sound that is, 1 microphone to 50 microphones simultaneously. And that distorts the image of the picture for the user who wants to experience it in an Atmos environment. We had geopositional information of all of the microphones. I say you have to think like lighting now. Audio has to start thinking a lot more like lighting. So in this case, I have the geopositional information of the center, and I have the geopositional information of all of the microphones relative to that center. I also carry the height of the microphone and the bearing of the microphone as part of my database structure. And these microphones aren't moving, they're not dynamic, it's just information I have about my stream. It's the description of my session. We laid out a switch setup, and to make it easy for operators, this is exactly what I gave them. I gave them a Google document, which was a Google presentation, and each one of these is a link to the switch that I want to connect. So by leveraging very simple shareable technologies, the audio operator could click on building.igmp.audio and they would have access to the switch. So I'm not presenting them everything. I'm just allowing them to know that they have access to these devices. With switches throughout the building, we showed up and the broadcaster would not ever allow us to be on their engineering network as a guest, as a rental company. The broadcaster is not interested in us leveraging their network. What they are okay with is leveraging trunk lines that exist through the building. So this building had fiber trunk lines to within every. You can't go 100 feet without hitting a trunk line. You could hit fiber, you could hit Ethernet, or they had SMPTE hybrid fiber cable, which we also leveraged with LC connectors to bring the audio over to the networks. We built a resilient network with multiple switches, so if we lost a switch, we would have half the show. But we were able to spread the microphones into smaller segments. And instead of everything pooling all in one place, we can actually segment the positioning of these devices and design a network so the paths back to the recorders are resilient. We took all the camera control unit feeds from the truck using an AES, And then we captured all of the microphones because they were not a network native microphone. They were an AES microphone with analog out through the receiver. So the broadcasters took one feed, and I took the analog feed. But what I was able to do was remotely control the head end of my device. So once it's on the network, I have actually some type of handle to go in and control the device. Like I said, I used 4 laptops to accomplish this 100-track record. And why did I use 4 laptops? Well, I had 5 switches, and at every switch, I sometimes needed to do configuration, so I'd be at that switch talking to people. And I'm like, well, that makes a great audio recorder. So I set up emerging virtual sound card on absolutely every machine. I took a microphone input to the network. I fed building LTC timecode to the network through a Primo, and that Primo stream went AES67 to all of the recorders. So track number 1 on the recorders was a distributed LTC signal through the network. I was able to access these machines in other trucks using virtual machines because it's, hey, I have this network I can leverage completely. And these tools have not been available to audio technicians as of yet. The thing I learned most about switches is the diagnostics of the device. Knowing that it's passing packets, knowing that it's dropping packets, knowing that it's consuming PoE, knowing that the PTP is boundary clocked, knowing those things is reassuring. I was looking at the EBU has a live stream tester as part of their booth, and it looks at all incoming streams and generates a SDP out of it. And I check out the EBU booth. My whole thing back to all of this is all of these are unique. The talent, the location, the MAC address. Person, mic, gear, MAC address, network. My job starts at the network now. This is the easy stuff. It's now that it's on the network, my job starts at the NIC. So if I know in advance, through an inventory system, what is actually going to be put onto the network, I can manage that data as it repeats and repeats and repeats. Talent, position, show, session description. So everything that I used to put on a piece of tape with a Sharpie marker, I include in the session description protocol. I use programs such as Ravenna to SAP to make announcements between the Ravenna devices, the Dante devices, and any device that wishes to see what the subscriptions are. I can make API presentations to production, to the mixer, to the air, and to the recorder. Having a common bit of information about the sources makes this experience so much better. I have a wireless microphone on me, and I notice that it has a name and it has an opportunity. I gotta say, every time I've handed somebody a microphone that had their name written in the LED, brings a smile to their face. But now, imagine if their tonal characteristics could travel with them. The talent, all of that is one object in all of these standards. So if I'm moving around one object that is the SDP, whether it's through SIP, whether it's through SAP, whether it's through MDNS, Bonjour, I can do that. Once those announcements are on the network, those announcements can be logged into the next stage, which is the archival recording. So part of my recording can be the capturing of the metadata announcements. Now, you can't record AES67, but you can packet capture it. And if you're packet capturing the RTP streams, you can also packet capture the announcement streams. So while you're packet capturing an event, you can packet capture all of the events around it as well. So with Ravenna to SAP, I can take a database of all of these devices and their transmitters, make announcements, and boom, I can have all of these proxy announcements localized to my network. Whether you can subscribe to it or not is dependent on the receiver, but some of these streams can be media rich and full of whatever I want. Like I said before, if my receiver doesn't care about the things that it doesn't know, I can put whatever I want in there. So there are certain things in the RFC that I like to call tape and Sharpie markers. And one of them is an attribute. And my obsession with AES 70 has led me down a rabbit hole of taking an OCA object, giving it an object number, like it's kind of a unique ID like a SNMP. You give it, this is the class of the device, so this is the class object, and then you have a block, a switch, and then you have its value. So I can tell by transmitting the SDP what actually is in the device, what is the gain of the device, what is the status of the device, and move that around from device to device. And I can include that in my disconnection, my connection, and configuration of all of the devices. By bringing all of these standards together, by bringing mechanisms like IS-04 and IS-05 together, you start seeing these network devices become Internet of Things devices. The common language of the SDP is already there, and it's something that we can move around with quite great ease. Thank you very much. Do you have any questions?
Thank you, Anthony. We have time for a question. Okay. Actually, I did have one quick question. Where do we stand? I mean, do you see these becoming standardized? Do you see these additional attributes being adopted widely in the industry?
I don't. I think that you can do whatever you want, and now computer engineers are replacing broadcast engineers in the departments of production facilities. And those demands of those computer engineers need a mechanism to standardize on. And I don't think it will ever be standardized. But I know that taking a look at AES 70 and those types of established control protocols mirror similarities in Yang, mirror similarities in SNMP, mirror similarities in KLV, TLV presentations. So there are opportunities to leverage other standards. The one standard I know for sure that everybody leverages is this one. So that's why I chose to put all that information in that one. I can have an event, but once that event happens, the event is logged, and I can keep a running track of my connection makes and breaks, and I can keep track of what is absolutely going on. But there are other, like the MQTT protocol for Internet of Things devices to get real-time information, such as levels. It's not something I'm going to log all the time. But if I see connections and disconnections and big changes, that's a big deal. But level indication, there are other protocols and stuff for that. So there's different ways to do that. Thank you very much. Appreciate it.